In this problem, I will be converting a rate using a formula and using a dimensional analysis approach. We are told that we need to give 30 mLs of NS via a bolus, and that needs to be administered over 30 minutes. And we're using a gravity system that has a micro drip tubing. We need to figure out the rate in drops per minute. Using a formula approach, I've already gone ahead and wrote down that formula. We would need, in order to find the rate, we would need the volume given in milliliters. We would need to know the drop factor, the ratio in this case of how many drops are contained per milliliter, and we would need to know the time in minutes. Plugging them into this formula and simplifying will result in a rate, and that rate will have a unit of drops per minute. So I'm going to go ahead and think about what information I'm given. I know the volume in this case. I'm looking for the rate, so that's not going to change. I know the volume to be infused is 30 mLs. That is the volume. So I've already gone ahead and inserted the 30 mLs. I am going to skip the drop factor for now because the other piece of information that I know that's obvious is this 30 minutes. This needs to be provided to the patient over a period of time of 30 minutes. The drop factor is given in this problem, although it's kind of hidden within one phrase. We are told that we have micro drip tubing. Micro drip indicates that the ratio of drops to mLs is 60 drops. That means for every milliliter that we have or that the patient will be receiving, that milliliter, so if this was 1 milliliter, this would be broken into 60 drops. 60 tiny drops is going to be how this milliliter is broken up into and infused into the patient. So that means our drop factor in this case is 60. What we find when we simplify 30 times 60 divided by 30, we will produce this unit of the rate, which in this case will be just 60. So that means we would need to have 60 drops per minute, or that's how many drops per minute the patient would be receiving. Using a dimensional analysis approach, we know with dimensional analysis, if we're converting a rate, we're going to start with what we know. The starting rate in this case, we know that the patient should be receiving 30 mLs for every 30 minutes. I do not want a unit of milliliters per minute. I know at the end of my conversions, I need to have drops in the numerator and minutes in the denominator. I already have a unit of minutes, so that does not need to be converted. I need to cancel out a unit of mLs, and I need to convert that into a unit of drops. Well, thankfully, I am given that information. That is the drop factor. I know that every milliliter will contain 60 drops. So multiplying by 60 over 1 will convert my unit of milliliters into a unit of drops, and once again, you will get 60. So depending on your approach, you still get that same solution of 60 drops per minute.